Hello and welcome. In this video, we start our discussion about limits of functions. We will see limit notation, we will learn how to read the limit notation, and what is the meaning of the limit of a function. To start our discussion, consider the function f of x equals to x squared minus 3x minus 2 over x minus 2. Here we have a graph of this function. And as you can see, it's very similar to line, but the main difference between the graph of this function and line is that it has a hole on it. The function is not defined at 2. When x is equal to 2, there is no y value for this function. This function is not defined at 2. If we want to plug in 2 in this function, denominator of this function, which is x minus 2, will become 0. So this function is not defined at 2. Now we want to investigate the behavior of this function around point 2. We want to know what happens to the y value of this function when the values of x get closer and closer to 2. Note that when we say x approaches to 2 or x is near to 2, x can be on either side of 2, left side or right side. But x is not equal to 2. It is only very close to 2. To answer the question of the behavior of this function for the values of x near 2, I have made two tables of the values of this function. In the first table, the values of x get closer and closer to 2 from the left. In the second table, the values of x get closer and closer to 2 from the right. In the first table, if you notice to the values of x, all of them are less than 2. They are in the left side of 2. In the second table, all the values are greater than 2. So they are in the right side of 2. So in the first table, we get closer to 2 from the left. In the second table, we get closer and closer to 2 from the right. If you notice to the values of this table, as x get closer and closer to 2, in the both of the tables, when x get closer and closer to 2, the y value get closer and closer to 5. So from the left side or from the right side, as we get closer and closer to 2, the y value of the function approaches 5. They get closer and closer to 5. In the first table, if you notice, when x is 1.999, we are very close to 2. The y value is very close to 5. It's 4.998, which is very close to 5. Also in the second table, if you notice, when x is 2.001, the y value is 5.002, which is very close to 5. So when we get closer and closer to 2, the y value of the function approaches 5. From the table of the values of this function, and also from the graph of this function, we can see that the closer x is to 2, the closer our function is to 5. And we can express this by the limit of our function as x approaches to 2 is equal to 5. And the notation for this in the limit form is limit of 2x squared minus 3x minus 2 over x minus 2 as x approaches to 2 is equal to 5. Again, note that how I read this notation. Limit of our function 2x squared minus 3x minus 2 over x minus 2 as x approaches to 2 is equal to 5. Maybe you ask yourself how we can find limit of our function without looking at the table of the values of the function or without looking at the graph of the function. And this is the topic of our next videos. For now, you should be able to read and write the limit notation and have an idea of the meaning of the limit of a function. Don't forget that the limit of a function is about the behavior of a function around a point, close to a point, not exactly at that point. And one more thing that you should stick in your head is that when we say x approaches to a point, for example in this case 2, x is on either side of 2. Now is the time to see the general notation of a limit of a function. This is the general form of the notation of a limit of any function f of x as x approaches a equals L. And the meaning of this notation is that the values of the function f of x gets closer and closer to the number L as x gets closer and closer to a. And again, don't forget, from either side, from the left or from right side of a. And again, I should emphasize that as x approaches to a, x is not equal to a. X is only very, very close to a. Thank you.